when we look at the columns in for closed data, latitude and longitude, they all have missing values. We can take a look at the info again, and it tells us that this 829,000 versus 910,000 is obviously the missing values here. Similarly, for latitude and longitude, we have missing values as well. So let's get rid of all of them. What the heck? We don't really want missing values, so we'll throw them all out. And this we can do very simply by using the same procedure that we use for incident zip, but here I'm going to use a logical operator in the middle of the conditions. And in the pandas world, the logical operator that we use in conditions is not the AND or 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 NOT as in Python, but we use an ampersand as an AND. This would be an OR. Oh, sorry, this would be an OR, the pipe character, and this would be a NOT, the exclamation point. So that's how that works inside pandas. So what we're going to say here is that we want to include only those lines that have a not null value for latitude, a not null value for longitude, and not null value for closed date. So that should take care of that. Let's run this and look at the info here. And now we're down to 806,000, and they're all the same. So now we have a data frame that contains data that is all not null. Right? We've hopefully got rid of all the null values. So that's the next step. The next thing we can do is we can start looking at the burrow data and seeing. Our goal is to clean the data. So what we really want is a data frame that contains data that is meaningful to us. So we want to look at every column to see whether the data in that thing makes sense or not. So let's take a look at the second column, the burrow column, and another column, burrow column. We look at that and we look at the unique values there, and we find that we have 6 values, even though there are only 5 burrows, and there's one burrow that says unspecified. Right? So that's a problem for us, right? What is an unspecified burrow? So we can of course remove it, but before removing anything, we should also look at the data itself to make sure whether that removal is not going to cause us problems down the road. And what are the problems down the road? You don't want to remove data systematically from your data frame, because otherwise your analysis is going to miss out on some systemic property that is useful, right? So you typically want to see that if you're removing data, that the data is occurring reasonably randomly inside it. The problematic data is occurring reasonably randomly inside your data. If that is the case, then you can get rid of it. It's not going to affect your analysis. However, if there's a systematic reason why we have unspecified in our database, then we should probably keep it, okay? Because we want maybe something useful that we get out of it. So let's see what we get from here. So what I'm going to do is I'm going to say, all right, show me the data that has the value of burrow unspecified. So this is what we are saying here, data burrow equals unspecified, and we are extracting this from the data. And from there, we're going to look at the 2 columns, agency and incident zip, just to see whether there is some whether the unspecified burrow occurs systematically across agency or incident zip. All right, so that's the goal here. In reality, like I said, there's something like I think 60 or 70 columns in that database. So you really need to look at it in more with the entire data set, but we are working with a smaller data set because of limitations of the speed of processing and the fact that we have to upload and download all this data. So we look at this here, and we run this through here, and we look at this, and we look as just looking at eyeballing it, it looks like there's lots of NYPD in this thing here, right? Lots of them are NYPD. So we want to find out now, is that really the case? So let's take a closer look at this. So what we'll do is we're going to use the group by function, and we'll look at this in more detail later. But the group by function, what it does is it groups data in a data frame by groups, which is somewhat like the SQL group by that we saw last week. It does pretty much the same thing. So what we're going to do is we're going to look for extract the data for unspecified burrow, then group it by the agency, so that we get the agency groups by NYPD, DOS, DOE, Department of Sanitation, etc., and come out with a count by groups. Okay, so we can take a look and see whether we have some kind of a bias here in this. So we look through this stuff here, and we find that we've got well, this is all, it's going to be the same in every column, but we have 67 rows for the housing department. That's DHS, I think it's housing, I'm not 100% sure, and 725 for the New York Police Department. So clearly there is a bias here of some sort, because 725 cases are NYPD cases. So the New York Police Department tends to do a lot of unspecified stuff. What we want to do next is then find out, is this a significant proportion of NYPD cases? Maybe if it's a small proportion, we can still ignore it. And like I said, there are very many more columns here. So there may be, if we had all the columns, we might find that there are certain kinds of NYPD complaints that come with unspecified borough, like maybe they're TLC complaints, complaints on moving violations of a certain type, okay, something like that. We don't know, right? We don't have all the data, but that would be what we would want to see. We want to see whether there is some systematic reason for that. But right now, all we know is that, hey, we got 725 cases of unspecified boroughs for NYPD, and we want to find out, are these a significant proportion of NYPD complaints or not? So let's see if we can figure that out. So what we'll do then is we'll say, all right, we want to find the total NYPD complaints. So let me run this piece by piece so we can take a look at each step. Comment that, comment that, comment that, and run this. So this, what this does is, we are counting here the number of cases where the agency is NYPD. Very straightforward. So let's see what that is. Complaints total. It tells us 274,408. So we got 725 out of that. That doesn't look like a huge amount, but let's get the exact number, exact percentage. So here what we're going to look at is how many are, let's run that. So 725. So we've got, these are the cases where we have NYPD and an unspecified borough, and then we can divide the first number, the second number by the first number to figure out the percent of cases where NYPD is unspecified and it is NYPD. So a percentage of NYPD complaints that are unspecified, that have an unspecified borough, and that's 0.26%. It's not a huge number. And like I said, what we would like to do, of course, is take this data and look at the entire data set and then see whether there is some kind of systematic reason for these 0.26% cases, but we don't have all that. So what we'll do is we'll just chuck them, okay? We'll throw them out. And because for one thing, it's going to be hard to explain that when we are presenting our results to management or whatever. We'll say unspecified borough, and they'll say, what the heck is that? So what we'll do is we'll take our data and say, include only those elements in our data where the borough is not equal to unspecified. So this is where borough is Manhattan, Queens, Brooklyn, Bronx, or Staten Island. So this notice our not sign over here, right? It says not equal to. This is actually pretty common in computer programming languages. Python is a bit of an exception with the A and D stuff. So that takes us through to that, and let's take a look at our thing now. So it's cell below. And what do we have now? Data.info. And we are now down to 805,000 from 970,000 approximately. So we lost quite a bit of data in this process. So we need to be careful, right? We've lost, I think, like almost 170,000 lines of data. So that's a pretty hefty chunk of our data, 10%, more than 10%. So we should be a little bit careful when we think about this. If you're losing a lot of data, we're going to lose a lot of meaning in analysis as well, right? So I'm going through this very, very quickly, but in reality, you want to take a lot of pains over figuring out whether something should be retained or not retained in your data set.